Our planet is a tapestry of land and water. Vast oceans blanket most of the Earth. Towering above these waters are the continents, islands of rock and life. These landmasses are not just home to diverse ecosystems, they are powerful forces that shape our climate. Continents influence everything from temperature to rainfall. They dictate the flow of air and water. Continents act as giant heat sinks. They absorb solar radiation. They release this heat back into the atmosphere. The size and location of a continent directly impact how it interacts with the sun's energy. This, in turn, influences global weather patterns. For example, the massive landmass of Asia plays a major role in driving the monsoon seasons. Continents are not static entities, they are constantly on the move. The Earth's tectonic plates are in a slow, relentless dance. This dance has shaped our planet over millions of years. It continues to influence our climate today. Join us as we delve into the fascinating relationship between continents and the climate they create. Imagine standing in the heart of a vast desert. The sun beats down mercilessly, the air shimmers with heat. Now picture yourself on a small island. A cool ocean breeze whispers through palm trees. Larger continents experience more extreme temperature variations than smaller land masses. This phenomenon is known as continentality. Land heats up and cools down much faster than water. Large continents, located far from the moderating influence of oceans, experience greater temperature swings. Coastal regions, on the other hand, enjoy milder climates. The ocean acts as a giant temperature regulator. Consider the example of Asia, the largest continent on Earth. The vast interior regions of Asia, far from any ocean, experience scorching summers and frigid winters. Understanding continentality is key to understanding the diversity of climates found across our planet. Our planet's surface is not static. It is a dynamic, ever-changing landscape. The Earth's outer layer, the lithosphere, is broken into several large plates. These tectonic plates float on the semi-molten asthenosphere below. Driven by convection currents deep within the Earth, these plates are in constant motion. They collide, separate, and slide past each other. This slow but relentless dance is the engine of continental drift. The movement of tectonic plates has a profound impact on climate. When continents shift their position, they alter the flow of ocean currents. Ocean currents act like giant conveyor belts. They distribute heat from the tropics to the poles. Changes in ocean currents can lead to regional warming or cooling. The collision of tectonic plates can also trigger volcanic eruptions. Volcanoes release massive amounts of greenhouse gases, such as carbon dioxide, into the atmosphere. Understanding the link between plate tectonics and climate change is essential for comprehending the long-term evolution of our planet. Ice sheets, vast expanses of ice covering large land areas, play a critical role in regulating Earth's climate. These frozen giants have a high albedo, meaning they reflect a significant portion of incoming solar radiation back into space. This reflectivity helps cool the planet. The formation and growth of ice sheets are influenced by several factors, including temperature, precipitation, and the distribution of continents. Continents located near the poles are more likely to develop extensive ice sheets. Ocean currents also play a crucial role in climate regulation. These currents act as giant conveyor belts, transporting heat from the tropics to the poles. For example, the Gulf Stream, a warm ocean current, carries heat from the Gulf of Mexico northward along the eastern coast of North America. This current helps moderate the climate of Western Europe, making it warmer than other regions at similar latitudes. Understanding this delicate balance is crucial for predicting future climate scenarios. Section 5. Mountains, volcanoes, and the breath of the Earth. The Earth's surface is sculpted by powerful forces. Tectonic plates collide, pushing up towering mountain ranges. Volcanoes erupt, spewing molten rock and ash into the atmosphere. These geological processes not only shape the landscape, but also profoundly influence our planet's climate. Mountains act as barriers to atmospheric circulation. As air masses encounter mountains, they are forced to rise. This rising air cools and condenses, leading to precipitation on the windward side of the mountains. The leeward side, however, often experiences a rain shadow effect, resulting in drier conditions. Volcanic eruptions release massive amounts of greenhouse gases, such as carbon dioxide, into the atmosphere. However, volcanic eruptions can also release aerosols, tiny particles that reflect sunlight back into space. The interplay between mountain building, volcanic activity, and atmospheric circulation highlights the dynamic nature of our planet and the complex factors that influence climate. Section 6. The rise and fall of the oceans. The oceans, covering over 70% of Earth's surface, are not static bodies of water. Their levels have fluctuated dramatically throughout Earth's history. These fluctuations, driven by a variety of factors, have had a profound impact on coastlines, ecosystems, and global climate. One of the primary drivers of sea level change is the growth and melting of glaciers and ice sheets. During glacial periods, vast amounts of water are locked up in ice sheets on land. This reduces the volume of water in the oceans, leading to lower sea levels. Conversely, during interglacial periods like the one we are currently in, melting ice sheets contribute to rising sea levels. Tectonic plate movements can alter the shape and depth of ocean basins. Changes in sea level can have significant impacts on coastal regions. Understanding the factors that influence sea level change is crucial for predicting future impacts on coastal communities and ecosystems. Section 7. Supercontinents shaping climate over eons. Imagine a world where all the continents are joined together in a single massive landmass. This supercontinent, surrounded by a single vast ocean, represents a dramatic departure from our current world map. Such supercontinents have formed and broken apart multiple times throughout Earth's history, each time leaving an indelible mark on the planet's climate. The formation of a supercontinent can have a profound impact on ocean currents. With a single, vast ocean, the circulation patterns of ocean currents are significantly altered. This can lead to changes in heat distribution, affecting global temperatures and precipitation patterns. The presence of a large landmass can also influence atmospheric circulation patterns. Large continents can create monsoonal circulations characterized by seasonal shifts in wind direction and rainfall. The breakup of a supercontinent leads to the formation of new ocean basins and the separation of continents. Understanding this cycle provides valuable insights into the long-term evolution of our planet's climate system. Section 8. A cooling Earth. The legacy of continental change. Our planet has been on a long-term cooling trend for the past 50 million years. This cooling trend, while punctuated by periods of warming, has led to the current icehouse climate we experience today. Continental drift, the slow but relentless movement of Earth's tectonic plates, has played a significant role in this cooling trend. One of the primary ways continental drift influences climate is through the alteration of ocean currents. As continents shift their positions, they can block or redirect ocean currents, disrupting the flow of heat from the tropics to the poles. This can lead to regional cooling, particularly in polar regions. The formation of the Himalayan mountain range and the Tibetan plateau, a result of the collision between the Indian and Eurasian tectonic plates, is a prime example of how continental drift can influence climate. This massive uplift altered atmospheric circulation patterns, contributing to the development of the Asian monsoons and the cooling of the northern hemisphere. Understanding the legacy of continental change is crucial for comprehending the long-term evolution of Earth's climate system.